In the early years of learning mathematics, we hear a lot about equality. That's where things are equal. And there are things that are a lot easier to understand about equality, just to say that this is equal to that, okay? It's just equal to one number. But not everything can be best described using equality. Put another way, not everything is equal. So we use something else to describe those situations, those unequal situations. We use what we call an inequality, where things are not equal. It could be equal to a number, but it could also be more than that or less than that. An inequality has a whole range of possible answers. Now, to be clear, we're talking about inequalities in terms of numbers, so about quantity or expressions that aren't quite equal. And inequalities are actually really common in life. Like in the example of an architect. Maybe an architect is being told that she can't build a building more than 1,000 square feet. At most that she has to work with is 1,000 square feet. When we use that phrase at most, we're describing an inequality. She could go up to 1,000, but couldn't go any more than that. But she could go less. That's an inequality, at most 1,000 square feet. She could design the building using the full 1,000 square feet, or it could be less than that. Or a business might say, we need to make at least 500 sales this month. That's the bottom number, that 500 sales, but they could make more and probably want to make more. That's an inequality as well. That bottom number is 500, that's at least 500, but they can make more than that as well. Or like a data scientist who says that a certain presidential candidate has an 80% plus or minus 3% chance of winning an election. They do have an 80% chance, but it could be 3% more than that, or it could be 3% less than that, depending on that margin of error. Okay? That's a range of numbers, so it's not exactly equal to 80%. It could be more or less than that. That's an inequality. In all of these situations with the architect or the business or the data scientist, things could be equal to the numbers that they say, 1,000, 500, 80%, or it could be more than that or less than that. That's what makes it an inequality. It could be a whole range of numbers. So because inequalities show up a lot when we're working with numbers, we need to understand them. So in this whole unit, we'll be working with inequalities so that you can become more familiar with them. In this particular lesson, we'll be working with graphing inequalities on a number line so we can gain a visual idea of what they look like. All right, let's look at an example of an inequality. Okay? Here we have an inequality. Now, normally when looking at an expression like this, we might see an equal sign here. It says x equal to 17. That would be an equality because x is equal to that one number, 17. But here we have a different symbol, a symbol that you've seen before. This is the less than symbol. And so what that's telling us is that x is not equal to 17, it's less than or smaller than 17. So let's break it down a little bit more. Hey, we have our x here. Hey, that's our variable. Remember, that represents an unknown number or solution. In this case, it's going to represent a whole bunch of numbers, a whole bunch of different possible answers or solutions. So what this is saying is our unknown number here, our unknown solutions, are less than or smaller than 17. So instead of our answer being equal to 17, we have all of the possible answers are any of the numbers that are less than 17 or smaller than 17. Okay? And so that could be 16, that could be 15, it could be 2 or 0, it could be negative 500. All of those numbers are less than 17. And so when we're looking at an inequality, we want to understand how do we read that. Okay? We read this as some number is less than 17. Or a better way to maybe say it is all of the numbers that are less than 17. Because as I said before, with an inequality, we could have a whole bunch of answers. Now there are other symbols we'll look at that go with inequalities, and we'll look at that in just a second. So as I said, we'll be graphing these inequalities on a number line in this lesson. So let's look at some examples of that and try to understand what's going on. So up here at the top, okay, we see x equal to 3 and a number line. Okay? Let's first look at what does it look like to graph an equality on a number line. Well, first we know we number line, we start with 0 in the middle, and then all the numbers, all the positive numbers off to the right, all the negatives off to the left. Okay? And so if we're graphing x is equal to 3, we would just put a point or a dot at 3 on that number line. Because what that statement is saying, x is equal to 3, is that that is our one solution. It's not equal to anything else. It's just equal to x equal to 3. Okay? So that's how we'd graph it. But with an inequality, because as I said, there could be a whole bunch of answers, it looks a little different. So look at this example here. This statement, x is greater than or equal to 3. Okay? So this is the greater than or equal to symbol. And so if we're going to graph that, okay, you can see here that we've got this filled in circle here at 3, but then there's an arrow pointing to the right. Well, look at that statement again. X is greater than or equal to 3. All of our possible answers and solutions are greater than or equal to 3. So 3 is a possible solution, so we put a filled in circle there, but then we draw an arrow towards the direction of all the numbers that are greater than 3, okay? So off to the right, okay? Like 4, 5, 6, and so on. So that's how I would graph this, is I would put the filled in circle where 3 is, because it could be equal to 3, but it's also all the numbers greater than 3. So I would draw the arrow off to the right to where the numbers are greater than 3. Or in this example, it's x is less than or equal to 3. So that's just the reverse of it. Okay? All of our possible answers and solutions are less than or equal to 3, so 3 is right here. Again, we fill in that circle, but then we draw the arrow towards all the numbers that are smaller than 3, okay? Or less than that. So I'm just reading this expression, this inequality, and that's telling me how to graph here. These two, you notice this one just says x is greater than 3, not equal to. So I use an open circle because it's just greater than 3. It does not equal 3 at all. This one did. It could have been 3 and also greater than 3. This one is just all the numbers x greater than 3. So open circle on 3 and then arrow to the right because it's all the numbers that are greater than 3. And then x is less than 3 is just the opposite. Open circle on 3 because it's less than 3, it's not equal to it. And then all the numbers to the left that are smaller than 3. That's what x is less than 3 looks like on the number line. So you want to read and understand what's going on here, okay, in this statement, read and understand what that's saying, and that will tell you how to graph. All right, let's look at some examples in your note packet. This is the first page, Introduction to Graphing Inequalities. We're just going to cover the first part of it, or about half the page. So we're graphing these inequalities, and so we need to understand the symbols and how to read these inequalities. So let's start with the symbols needed for graphing inequalities. This first one, this filled in point or dot, that represents equal to. Okay? So we need that filled in dot if we're saying that something is equal to a number. And we can kind of know when to use that if we see the less than or equal to or greater than or equal to symbols. Okay? If we see those two symbols, then we know we're going to use the filled in dot. If we see an open dot or need to use an open dot, that represents not equal to. We're saying that we may be starting at this number, but it's not equal to that number, maybe more or less than that. And when you see the less than or greater than symbols, that's what we're going to use, is the open dot or open point. So let's look at how do we graph these inequalities. On A first, okay, we have x is less than 2. Okay, x is less than 2. So as we read this inequality, that's telling us how to graph, okay, and what we need to do. So what this is saying is that all of our values, okay, all of our numbers, are less than 2. Okay? So we first need to put some numbers on our number line. Okay? So remember we've got 0 somewhere, and you can put it, if you want to put it towards the middle, 0, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. Okay? And so my inequality is saying x is less than 2. So because it says less than, I'm going to use an open circle. Okay? Because it says less than. So I'm going to put an open circle at 2 because it's not equal to 2, but we're starting at 2. And the inequality says x is less than 2. So all of the numbers that are smaller or less than 2. And that's to the left. So I'm going to draw an arrow. And you probably don't have different colors, and that's okay. Just kind of mark it, really thick with your pencil. You can use different colors if you have them available. And so, what this inequality x is less than 2, this is what it would look like as a graph. An open circle at 2, and then an arrow to the left, because that's all the numbers that are less than 2. Let's look at another one. B. X is greater than -3. Okay? X is greater than -3. So again, I'll put 0 somewhere on my number line, and then I'll fill in my numbers 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. Okay? So I just put some numbers on the number line. And my inequality says x is greater than -3. Okay? So I'm going to start at -3, but I'm going to use an open circle because it just said greater than. It didn't say greater than or equal to, it just said greater than. So it's not equal to -3. But it does say greater than, and so that's all the numbers bigger or off to the right of -3. And so that's what that graph of that inequality would look like. Okay? So you got two things there. Figure out what circle are you using, the open or closed circle, and which direction are you going. That's what you're trying to figure out. Let's look at a couple more. C, x is less than or equal to -1. X is less than or equal to -1. So this one has the less than or equal to symbol, so I'm going to use a closed dot for this one. So again, let's put our numbers on the number line, 0, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. And since it's x is less than or equal to -1, we put our closed dot at -1 because it could be equal to -1, but it's also all the numbers less than that, so off to the left. Okay. So again, this phrase is informing what this looks like. Okay. X is less than or equal to -1. Let's do one last one. D, x is greater than or equal to 5. I'm going to switch up my number line a little bit so that I have more room to show, x is greater than or equal to 5. So I'm going to put 0 down here. I'll do -1, -2 over here. Okay. So I just switched up where my 0 was so that I would have more space to show the numbers greater than or equal to 5. So it is greater than or equal to, so I have a closed dot at 5. And since it's greater than, move all the numbers to the right of 5. Okay? So what this inequality is saying is that the possible answers or solutions or whatever it is you're talking about, it could be equal to 5 or it could be any of the numbers greater than 5 as well. The example that I was given in class the other day was, if you want to make at least $5, okay? For whatever it is, you need at least $5 to go buy something. Well, that means you could have $5, but you could have more, right? You could get more. That's what it means to have at least. So if we're saying x is greater than or equal to 5, it means we're at least 5. Okay? 5 could be equal to 5, or it could be everything more. So again, these inequalities and what this symbol is and where this number is informs what my graph looks like. Okay, so we need to know how to read this, what symbol to use, open or closed, and then which direction the arrow is going.